Hello class, I have a fun activity for you today. Do you want to join me? Let's look at what I have. I have first fraction equals 1 over 2. Now I'm sure you guys know where 1 over 2 is on the number line. I know you can locate 1/2 as a point on the number line. But hold on for a second and listen to what I have, and then I'll have you do a fun activity. What I have here is I say create a second fraction by multiplying the numerator and the denominator of the first fraction by the whole number 2. Why 2? I just picked 2 for now. In another activity we can try a different number. So I have the first fraction 1 over 2. I'm going to create my second fraction by multiplying the top and bottom of this fraction by 2. So 1 times 2 is 2, 2 times 2 is 4. So I now have the second fraction. So look, I have now two fractions, 1/2 and 2 over 4. I want to locate both of them on the number line and just see what happens. So can you guys stop the video and do it? And then we can come back and talk about this. Okay, so what did you guys notice? Here's what I see happening. For 1 over 2, remember this is the unit segment, and the 2 in the denominator is telling me I need to cut up the unit segment into 2 equal pieces by length. So I'm just going to put it out there. I know you guys have graph paper. I don't, so I just kind of put it there. And I will write 1 over 2 here. The 1 tells me it is the first tick mark right immediately to the right of 0. So this point is 1/2 and this length is 1/2. Now I want to also put down 2 over 4 on the number line. How do I do that? Well, I'll look at the denominator. The 4 tells me the unit segment must be cut up into 4 equal pieces. Well, I already cut it up into 2 equal pieces. I think if I were to cut this piece into 2 equal pieces and this into 2 equal pieces, that would make my 4 equal pieces by length. Would you agree? So this length is same as this length, the same as this length, is the same as this length. Now you guys have been practicing labeling points like this by the fraction symbol. So let's do that. This segment is cut up into 4 equal pieces. So you know the first point is called 1 over 4. And here I suppose we could have called 0 over 2 in the past. We can also call it 0 over 4. So this is 1 over 4. This is 2 over 4, 3 over 4, 4 over 4, and so on. What do we notice? Look at this point. I'll really thicken it so we can see. What do you notice about that point? What is that point's name? 1/2, and it's also 2 over 4. So what are we noticing from this picture? 1/2 is that point. 2 over 4 is also the same point. So what does that mean? That means we are saying 1/2 equals 2 over 4. Why is that? 1/2 and 2 over 4 are exactly the same point and on the number line. And remember we said every point on the number line is a number. So 1/2 and 2 over 4 are the same point and hence the same number. That's why we can put an equality sign in between them. So how did they end up being the same number? What did we do? We took the first fraction, we multiplied the numerator and denominator by the number 2. So can we try a different number and see what happens? So let's try that. Okay, I kept my first fraction as 1 over 2. Let's try to create our second fraction by multiplying the numerator and the denominator by 3, the same number 3. So if you do that, figure out for me what fraction do you get, what is your second fraction that you can get by multiplying this number by 3 and this number by 3. Write that down and then plot on the number line both 1/2 and the first fraction and also this new fraction that you get. So do that as an activity on your number line, and then we'll come back and discuss what that is. Okay, so I'm guessing this is what you did to get your second fraction. I'm guessing you went 1 times 3 is 3. 2 times 3 is 6. So I'm guessing your second fraction was 3 over 6. Did you guys get that? Okay. Now I'm guessing to plot 1/2, you did just as before. This is the unit segment. The 2 is telling you cut it up into 2 equal pieces. I just did, and that is 1/2, and I'll write 1/2 here. I know we can label these guys by a fraction symbol. I'm just going to label this point as 1/2 and leave it in that. Now I want to look at 3 over 6. Which point on the number line is really 3 over 6? And I'm guessing you said, well, 6, the denominator is telling us the unit segment must be cut up into 6 equal pieces. Well, we already cut it up into 2 equal pieces. And if I cut this into 3 equal pieces, and like this, and I'm guessing since you used graph paper, you probably had an easier time cutting it. So now I do have the unit segment cut up into 6 equal pieces by length. 1, 2, 3, 4, 5, 6. There are my 6 pieces. If I start labeling these points, which you know are fractions, then what happens? Well, this guy, you know, is 0 over 6, 1 over 6, 2 over 6, 3 over 6. This is what I was interested in. And now you guys, if you want, you can continue labeling. I'm going to stop because I really wanted to see what happens to 1 over 2 and 3 over 6. What's the relationship? What do you guys see? Do you see what I see? 1/2 is this point, 3 over 6 is this point. What is this point? A point on the number line is a number. This point is a number. So what we're saying is 1/2 is this number, 3 over 6 is this number. That means we are saying 1/2 is really 3 over 6. Are we getting at something here? What are you beginning to notice if you start out with a fraction and you multiply the numerator and denominator by some same whole number, and you think you have a second fraction, but so far, what is our experience telling us? In the past, you saw 1/2 is same as 2 over 4. Now you're saying 1/2 is same as 3 over 6. Let's repeat this activity for a different fraction. Okay, this time I have my first fraction as 2 over 3. And can you guess how I created my second fraction? So I took my first fraction and I multiplied both the numerator and the denominator by the same whole number. Can you guess which number that might be? Let's look at 2. What did I multiply 2 by to get 8? 4. And I did the same thing. I took 3 and multiplied 3 by 4 to get 12. So I multiplied both the numerator and the denominator of the first fraction by 4 to create my new fraction. 2 times 4 is 8, 3 times 4 is 12. Now I'm curious to know what happens if we were to locate both these fractions on the number line. So I want you to do that activity on graph paper, and remember when you draw your number line and when you draw a horizontal line and mark off a point as 0, you want to think carefully about where you want to put your 1, how many spaces later you want to put 1. Look at these fractions. You want to pick those spaces in such a way that in here you want to be able to divide the unit segment into 3 equal pieces. And also to locate 8 over 12, you'll want to divide it into 12 equal pieces. So did you guys get a hint? Perhaps if you, on your graph paper, if you picked 12 spaces between 0 and 1, that will make it easy for you to mark your 8 over 12 and also 2 over 3. So do that activity and check back with me on how I do mine. Okay, so here's how I do, I mark off. I don't have a graph paper, but let me try to mark off 2/3. To locate 2 over 3 on the number line, I take my unit segment and I cut it up into 3 equal pieces. And I'm just going to do a quick estimation. So this length is the same as this length, the same as this length. And as you know, this point is 1 over 3, and I won't write that. This point is the 2 over 3. So that's that 2 over 3 is that point, 2 over 3 is that number. For 8 over 12, the 12 is in the denominator tells me I must cut up the unit segment into 12 equal pieces. Well, I've at this time cut it up into 3 equal pieces. And if I were to cut each of these pieces into 4 equal pieces, then I'd have 4 pieces here, 4 here, 4 here. That would give my 12. So let me go ahead and do that. And to make it into 4 equal pieces, it's most convenient for me to split it up into 2 first and then 2 more. So there's my 4 equal pieces. 1, 2, 3, 4. And here again, I'll do 4 equal pieces. Here again, 4 equal pieces. Okay. So I have 4 pieces, 4 pieces, 4 pieces. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there are my 12 equal pieces. And I need to find the 8th multiple of 8th tick mark to the right of 0. Because remember, 8 over 12 is the 8th multiple of 1 over 12. And we know this first piece, that is the 1 over 12. And I'm looking for 8 over 12. 1 over 12, 2 over 12, 3 over 12, 4 over 12, 5, 6, 7, 8 over 12 matches up exactly where 2/3 is. That's not very surprising, is it? How did that happen? Well, we cut up each of the original 3 pieces into 4 equal pieces. Then what happened was this 2 was telling us that we had 2 copies of those 1/3. 2/3 is 2 copies of 1/3. So this is 1 copy and this is 1 copy. But next time when I went about making 4 equal pieces, then this piece got cut up into 4 equal pieces, and this copy of a third also got up into 4 equal pieces. So 4 and 4, 8. 8 over 12. So it looks like these 2 fractions are once again the same point or the same number. So when the 2 fractions are the same number, we write it this way. We use an equality sign and we say 2 over 3 equals 8 over 12. 2 over 3 is this point, 8 over 12 is this point. 2 over 3 is this number, 8 over 12 is this number. So that's why I can put an equal sign. So what are we beginning to guess? Let's quickly summarize everything we have done so far. So using the number line, using the same number line, you showed that 1/2 and 2/4 are the same point. So these 2 fractions are same. Sometimes we use the word equivalent. We can say 1/2 and 2/4 are equal fractions. We can also say 1/2 and 2/4 are equivalent fractions. So similarly, 1/2 and 3 over 6 on the same number line when you plot it with the same number. So these 2 are equal fractions or equivalent fractions and so on. You also saw this on the number line. I want to take a minute to convince you 1/2 equals 3 over 6. Also on what we call the area model. I'm sure you're already convinced 1/2 equals 3 over 6 because on your graph paper you sketched the number line, and on that same number line you plotted 1/2 and 3 over 6 and you got the same point. But well, let's take a minute and look at an area model. So for that, what I mean is, on the number line, let's pretend that this 1 is 1, or the whole represents the area of a unit square. A unit square is a square whose side lengths are exactly 1. So let's look at what the picture I have on this board. Okay, so here's a square and its side length is 1 unit. Okay, this length and this length are exactly the same. When I think of 1/2 of the area of the square, what we think is we must cut up the square into 2 pieces where each piece has the same area. It's easiest, there are many ways of doing it, and here I chose to cut it exactly like this. This length is same as this length, and because of that you can see the left piece is congruent to the right piece. I can lift this piece up and put it on the right piece and it will exactly match up. And congruent figures, as you can, I think it's believable, they have the same area. So you will believe half of the area refers to perhaps this piece of it. I'll even shade it for you. There, I've shaded half of the area of the square for you. So that's half of the area. What would 3/6 of the area mean? That means we must take the square and cut it up into 6 equal pieces, where equal means equal by area. There are many ways of doing it, and how about if we pick it this way? I will now make 3 cuts. Take this length and cut it into 3 equal pieces, and I'll use that line and go this way. Now notice, because of the way I divided, each of this piece is congruent to each of the 6 pieces, and each piece has the same area. So 3/6 means, look, I've cut up the square into 6 pieces, where the six equal pieces, where it's equal means equal area, and 3/6 means 3 parts of those 6. So it again goes back to the same shaded area, 1, 2, 3, 3 of those rectangle. So this shows 1/2 of the area is same as 3/6 of the area. So this is another way of convincing yourselves 1/2 and 3/6 are equal.